Let us discuss some of the applications of parallel plates, and one of the most common ones is a particle accelerator. So what you see, I've got my two plates arranged as such, and I simply put in an electron over here, and of course this is zero, this is some positive potential, and so the electron would then experience an electric force that's going to accelerate it from one plate to the other. And so this is a very common technique that we use in many applications, right? You will see this a lot, especially in your final year 12 or year 2, whichever course you're doing. And what we typically say over here, or one way to analyze this, we can use the conservation of energy. And so we can say that the loss in electric potential energy simply equals to the gain in the kinetic energy of this charged particle. And so remember that the loss in EPE can simply be calculated as Q delta V. And of course, this equals to half mv squared. And then we put in our values and you should be fine. You can figure out what is the speed of the charged particle at the other end of the plates. Another very common application or situation, should I say, that you will see is in particle deflection. And this is where you could have a charged particle, say an electron, entering a region of parallel plates with some velocity v. And of course, it will deflect because of the electric field. For an electron, again, this is Earth, so the potential here is zero. This is some positive potential. So you would expect the electron to experience an upward electric force the moment it enters the plates. And therefore, it starts to deflect in this direction. And in fact, this is a parabolic path because the force always stays the same no matter where you are because the field is uniform. And so we can always calculate this electric force using ma. So this will be the mass of your charged particle times a. And so the acceleration of this particle is the electric force over m, which we know is the charge of the particle times the electric field strength over m. And as we have seen, the electric field strength is simply the potential difference V over the separation of the plates T. Once you have the acceleration, you can calculate many cool things about this path because this just becomes parabolic motion. And so all our equations of motion, V equals U plus AT, S equals UT plus half AT squared, V squared equals U squared plus 2AS may all be used to analyze this motion once you have the acceleration. And so these are just some of the cool applications of long parallel plates and uniform electric fields.